Chapter 13 is all about trigonometry, and we're going to take it a step further than SOHCAHTOA. But the first section is going to be reviewing SOHCAHTOA concepts. So right angle trigonometry. If I'm given a triangle, and just so we remember SOHCAHTOA, for any angle theta, my opposite side length is going to be the side directly across from the angle. My hypotenuse is always directly across from the right angle. And my adjacent side length is the side that is not hypotenuse, but is right next to the angle. So SO stands for sine theta opposite over hypotenuse. CA stands for cosine theta is adjacent over hypotenuse. And TOA stands for tangent theta is opposite over adjacent. If I'm given this triangle and I want to find sine theta, cosine theta, and tangent theta, sine is going to be my opposite over my hypotenuse. Hypotenuse is always your longest length. So sine would be 4 over 5. Cosine is your adjacent over hypotenuse, which is 3 over 5. And tangent is your opposite, which is 4 over adjacent. Whenever possible, you should always reduce. Here I can't reduce any further. For the example problems, you should always try them by yourself first and then see if you get the same answer as I did. For sine theta, my opposite is 30 over my hypotenuse is 34. Here's a spot where you should reduce to 15 over 17. Cosine theta is my adjacent over my hypotenuse, which is 16 over 34, which reduces to 8 over 17. And tangent theta is my opposite over my adjacent, which is 30 over 16 and reduces to 15 over 8. There's two special triangles that we have. The first is a 30, 60, 90. A lot of times you see the side length across from 30 is labeled S. The side length across from 60 is labeled S square root 3. And the side length across from the right angle is 2S. My other special triangle that I have is a 45, 45, 90. This is where my two legs of my triangles are both labeled A, and the side length, the hypotenuse across from the 90 is A square root 2. Now if I have the problem, this would be a 30, 60, 90 triangle. So that means I know across from the 30 is across from 30 is S, across from the 60 is S square root 3, and across from the 90 is 2S. So if I want to solve for S, I can say 2S is equal to 100, divide both sides by 2, S will be equal to 50. So if I'm looking for X, X is the same thing as S square root 3, which is the same thing as 50 square root 3. Now, if you don't remember to use a 30, 60, 90 triangle, the other way that you could figure this out is I have my angle 60 degrees here, and I have my hypotenuse, and I'm looking for my opposite. So you could also say sine of 60 will be equal to my opposite over my hypotenuse. And here I would cross multiply. So 100 times sine of 60 would be equal to x. And if I were to solve this out, This would be equal 86.6 equals x, which is the same thing as 50 square root 3. So I do not care which way you pick to solve these problems. Here, if I have 145 measurement, that means both angles are 45. So this would be like my a, and this would be a square root 2. So if I'm looking for a, I knew a square root 2 is equal to 20 degree, or 20. So I divide both sides by square root 2. A would be equal to 20 over square root 2. You typically do not leave square roots on the bottom of a fraction. So what you do is multiply by square root 2 over square root 2. This is the same thing as 1. Anything multiplied by 1 is always the same answer. So I'd have 20 square root 2. Square root 2 multiplied by square root 2, the square roots cancel out, and I would just have 2. And now I can simplify the 20 and the 2 here. So 20 divided by 2 would be 10 square root 2. Again, if you want to do this the other way by using SOHCAHTOA, I'm looking for opposite and I have hypotenuse. So I'd have sine of 45 is equal to x over 20. And I multiply both sides by 20. So 20 times sine of 45 would be equal to x, which is equal to 14.4, which is the same thing as 10 square root 2. Whenever you see a word problem, you should always draw a picture. Here, a skateboard ramp will have a height. Pretend you didn't see that. Skateboard ramp will have a height of 12 inches, and the angle between the ramp and the ground will be 17 degrees. So that means my height is 12, and this angle is 17 degrees. It's asking what's the length of the ramp. So I'm looking for my hypotenuse. So I have my opposite, and I'm looking for hypotenuse. So I'll use sine of 17 will be equal to 12 over x. Here, cross multiply. X times sine of 17 is equal to 12. So I have to divide both sides by sine of 17. And I get x is equal to 41 inches. And finally, angle of elevation and angle of depression. If I have an angle of elevation, that means I'm looking up. So if this person's looking up to see the plane, this would be an angle of elevation, always looking up. If I have an angle of depression, that means I would be looking down. The person at the plane is looking down on the people, so this would be an angle of depression. So a surveyor whose eye level is 6 feet above the ground measures the angle of elevation to the top of the highest hill on a roller coaster to be 60.7 degrees. So if I draw a picture here, since I'm looking up, here's my person. Looking up, this angle would be 60.7, and it says that he is 6 feet. I also know the surveyor is 120 feet away from the base, or the hill's base. What's the height of the hill to the nearest foot? So I have to look for my opposite, and I have adjacent. So that'd be TOA. So tan of 60.7 will be equal to my opposite over my adjacent. Here, cross multiply. So 120 times tan of 60.7 is equal to x. If I multiply this out, I get 213.84 is equal to x. But I still have to include the 16 feet that the person is. So I have to add 6 to this, and my answer will be 219.84 feet. Your homework is on page 933, 1 through 9, 13 through 20.